For this BCI application pitch, I took this opportunity to explore how we can improve the lives of college students like myself. Now, if you ask many college students what they struggle with the most, you'll find that many of us have the same issue of sleep deprivation. Now, there are endless reasons why students lose sleep, ranging from caffeine and energy products to the good old classic all-nighter, and that comes along with an even longer list of dangerous side effects of sleep deprivation. Now, this includes memory and concentration issues, which could impact their learning, health or higher health risks such as diabetes, high blood pressure, and heart disease, as well as a weakened immune system, insomnia. I mean, the list goes on and on. But despite these dangers, college students continue to indulge in inadequate sleep hygiene. Today, I present to you an innovative smart home solution which revolutionizes the nighttime routine and promotes better sleep hygiene with minimal effort. I give you the EEPY CAP. The EEPY CAP is a groundbreaking smart home application which uses our advanced computer interface neurotechnology to promote better sleeping habits by automatically adjusting your home's lighting and temperature controls to create a sleep easy environment so you'll naturally feel ready to fall asleep at a good time. It will be implemented using a non-invasive, asynchronous, passive BCI system which monitors the user's drowsiness via analysis of their brainwaves. This means no surgery is required and the system will simply adjust the room's environment depending on your sleepy level while you're wearing the EP cap. First, users need to pair their EP cap to the EP cap app, which may be installed on their computer or phone. After creating a secure login, users must permit access to read their brainwaves while wearing the device. Once they've accepted these terms, they will use the stability indicator to ensure that the built-in electrodes can read their brain activity with stable contact to the scalp. From there, users can now pair the EPCAP app to their smart home devices and set their preferred nighttime lighting and temperature settings. For instance, if a user would like the ceiling fan to be turned on at medium power and would like the light to dim at 25% once they start feeling sleepy, they will select these preferences within the app in the Home Controls tab. The user will then have to complete a training to personalize their EPCAP to improve the readings on their unique brain. And finally, while the EPCAP has sufficient contact to the scalp, the application is ready to automatically adjust their smart home once it detects that the user is feeling sleepy. Now, before we take a closer look at the design choices, I'd like to show you how we've developed the criteria that determines one's sleepiness, as well as the metrics we've considered to analyze the user's affective state. According to research by the Sleep Foundation, as well as the scientific community, there is consensus that alpha brainwaves, normally at a frequency of 8 to 13 Hz, are a predominant brainwave pattern that develops when a person becomes drowsy and goes from being wakeful to being sleepy. This brainwave pattern continues until they are replaced by slower theta waves at only 4 to 8 Hz, indicative of light sleep. As a result, we will want to have electrodes in the posterior regions of the brain where alpha rhythms are commonly recorded, such as channels O1 and O2 in the occipital area of the 1020 EEG placement standard, as well as electrodes in the frontal and central regions where significant theta activity can be read, such as in channels F3, F4, C3, and C4. These brain rhythms are not specific to these areas. However, previous studies which monitored drowsiness in its participants have used a similar setup and have found these areas most effective. In addition to ensuring stable contact, the initial training setup will aid effective extraction of the raw EEG data by running the ICA algorithm within the EEG lab toolbox in MATLAB to remove artifacts or unwanted signals such as muscle movement or EMG, the eye movement or EOG, and heart movement or heart signals or EKG. This is especially helpful in eliminating interferences with the user's slower eye movements during the initial stages of non-REM sleep. As a result, the device can support limited non-stationary use such that the users can continue basic nighttime activities while maintaining good readings from the EPCAP. However, these activities should be restricted to low-effort tasks as more intensive actions may introduce significant interference with the EEG signals. These low effort tasks can be sitting at your desk while you're finishing your homework, or just relaxing while you're watching a movie on the couch. After this setup process, our application will use the filtered EEG data to analyze the band power of the user's alpha and theta states, therefore measuring their effective state via a combination of the fast Fourier transform algorithm and wavelet analysis to inspect the activity at their respective frequencies. If there is a notable alpha and theta activity indicative of drowsiness, your EP cap will signal to the EP cap app to adjust the home to the user's preferred settings, their preferred nighttime settings. If a user decides they want to override the EP cap adjustments, they can just simply do so by hitting the override button in the app and revert the smart home settings to how they were previously. However, after about 10 minutes, if the EP cap continues to read your drowsiness, it will try to adjust the room again, like a feisty EP cat nagging you to sleep. Finally, to support the user's comfort and electrode stability, we want to prototype our EP cap to have soft fabric combined with a stretchable elastomer and a comfortable chin strap. The electrodes will be safely stored in a conductive gel cap to facilitate effective readings on the scalp. During the prototyping and testing phase, we will ask participants of our studies to try out the EP cap at home without any smart home connection yet and simply self-report their feelings of sleepiness and drowsiness on a scale much like this so that we can compare our application's classifier and gauge its accuracy rate while detecting once they're reaching a sleepy state. This is much like the self-assessment mannequin, as the scale it uses images to remove any linguistic obstructions. Most participants will be permitted to minimal effort tasks like walking, talking, and typing, which will match the typical night activities of users. I'd like to take this time to quickly note the ethical implications of this idea. I've considered this and I've concluded that although this device delegates the preparation of our nighttime routine, the user's conscientiousness to wear the EP device demonstrates their willingness to even consider their sleep hygiene, which is a step in the right direction. Our app will serve as a guardian angel to help wrangle us back into bed where we should be when we are forgetful of the time or we're too distracted to realize what time it is. Furthermore, this issue isn't exclusive to college students and thus can serve to help those of all ages and improve society's sleeping habits overall. I am asking for an investment of $80,000, which will be budgeted over the next 10 months unless the product has been completed sooner. $35,000 to be spent on the personnel salary, $6,000 for EEG equipment and software costs, $4,500 for production and material costs, $5,000 for travel costs to conferences for industrial insights and recruitment opportunities. Office essentials and rent and utilities will be kept at $7,500 to as we can save money by working remotely from home. $10,000 for research and development and $12,000 for marketing and advertising. And I'll tell you what, if funds remain after this project is finished, we'll reinvest it into further improvements to enhance the classification performance of the EP cap and help it be better suitable for non-stationary use. Today, you have the opportunity to reawaken the people with ease and comfort, so please invest in the EP cap, and thank you for your time.